you should have these notes out from yesterday. We finished half of them. Today, it's still the same section, 2.4, solving equations with variables on both sides. This is technically video 3 on this lesson, okay? And on this lesson, we're going to focus in on special cases, right? So on the opener that we just did, we solved equations that had variables on both sides. We solved equations that had variables on both sides that required simplification, some distributive property and stuff like that. And let's move down to this part of our notes that we didn't get to yesterday. It says right here, some equations have a solution, some have no solution. Some have infinitely many solutions. And some, or you could just say all real numbers or identity. So we're going to be either using infinitely many solutions or all real numbers. I know it sounds weird right now. Let's start by looking at a special case of no solution. By the way, this is our learning target for today, to be able to solve equations that have special cases like no solution or infinitely many solutions. So here's an example of a no solution equation. So let's first understand that when you end up with something impossible, let's say you're solving this thing and you end up with something impossible like 0 equals 3. That just cannot happen. 0 does not equal 3. That's when you say no, as in no solution, right? So let's work on this guy. If we get to an answer, then that's great. But if something impossible happens like 0 equals 3, that's when we say no solution. So on the left side, let me zoom in even further. On the left side of this equation, I'm going to simplify it by doing what? Distributing, correct? Okay, you guys are asleep. So 2 times 3x is what? 6x. And then 2 times negative 4 is what? Minus 8, okay? And then I'm going to bring down the minus 5x that's left over, okay? So what I'm doing is I'm just focusing in on the left side and ignoring the right side. Actually, let me do this. There, I covered up the right side just so we could worry about the left side. So on the left side, I've already distributed. I need to now try to combine like terms. And combining like terms, I have a 6x here and a minus 5x here. You do not want to add 5x and add 5x. That would be adding 5x's to the same side. That would be incorrect. When you combine like terms, it's just simply doing it in your head. I would circle it, 6x, take away 5x. What's 6x take away 5x? 1x. So let's write that down. That's 1x. Let's bring down the minus and the 8. And there is absolutely nothing else I could do on this side of the equation. I can't subtract letters and numbers. So this is what we call a simplified left side of the equation. So now that I've simplified the left side, let me move this over. Now I'm just going to ignore this side, ignore that side, and just focus in on the right side. Is there any distributive property over here? No, but there is what? Combining like terms. So let me actually combine the 3x with the minus 2x. What's 3x take away 2x? That's 1x. So what I'm going to do right now is, first of all, get this equal sign and bring it down. So here's my equal sign. And let me combine, again, the 3x with the 2x with the minus 2x. That's 1x. And then the plus 9 is going to come straight down. So that's all I could do on the right side. There's nothing else to do. So now I want to look at my new equation. Let me move this out of the way. Let me actually write it nicer. We don't need the 1 in front of the x's. We already know it's 1x if there's no number in front. So we really have x minus 8 equals x plus 9. So we want to continue solving. What's the goal? To get x by itself on one side. So I need to get rid of one of these x's. You don't want x's on both sides of the equal sign. Right here we have x on the left and x on the right. We want to get rid of one of them. So what do? Let's get rid of one of them. Subtract one of them, right? So I'm going to subtract this x, so it'll cancel out. And what I do to one side, I have to do to the other. And then you say, wait a minute, x take away x, it also cancels out. Now that is really weird. It's a special case. This does not always happen. It's rare, but it does happen sometimes. What's left over, guys? We have negative 8 on the left side equals positive 9 on the right side. Negative 8 equals positive 9? That's impossible. It does not, nowhere is true, right? Negative 8 is not equal to positive 9. It's not. So what do we say? We scratch it out and we say no. No solution. That means that there is no answer. I'm asking you to find the value of x that'll make it a true statement, that'll make the left side equal the right side, and it cannot happen, right? I mean, this one's like multi-step, but here's a really simple one that you could clearly see cannot be true. Check this out. If I said x plus 1 equals x, I mean, in your head, think of a number that you could plug in right here and right here that'll make it a true statement. Give me a number. 5. 5 here, 5 over here. It's going to say 6 equals 5. It's impossible, right? Negative 1. Plug in a negative 1 here and a negative 1 there. It's going to say 0 equals negative 1. It's impossible, right? Or even if you went through the steps of solving, you want to get x by itself on one side? Okay, so let's subtract x and subtract x. You're going to have 1 equals 0. That's impossible, right? There's no solution, right? Whenever you get something impossible, we say no solution. Are we clear? Yes, we're clear. All right, good. So that's the special case where you end up with no solution. Now, let's check out this next part of our notes. It says infinitely many solutions, or infinite solutions, or all real numbers, or identity. We're not going to use the word identity. It all really depends on the book that we're using. Our book doesn't use identity. It says, I believe it says all real numbers. So let's start solving this example. And before we start solving, let's read it. If you're solving an equation and you do end up with something that is always true, like 3 equals 3, that's not impossible. That's always true. 3 equals 3. Then your answer is all real numbers. So let's start simplifying. I'm going to zoom in. Let me start simplifying the left side by distributing. So it's going to be 2 times 3x, that's 6x. 2 times negative 4 is going to be a minus 8. There you go. Bring down the minus 5x. And on the left side, we could still combine the x's. 6x take away 5x, that is 1x. Bring down the minus 8. Bring down the equal sign. And on the right side, there is no distributed property, but you could combine like terms. 3x take away 2x is 1x. Bring down the minus 8. And what do we have, guys? We have something that's identical. X take away 8 is equal to x take away 8. At this point, you could just stop and say that x could be any number you want. In other words, x equals all real numbers, all right? Because it doesn't matter if x is 3 take away 8 is negative 5, and 3 take away 8 is negative 5. That's a true statement. Or 100 take away 8, that's 92. 100 take away 8 is 92. 92 equals 92. That's a true statement. So at this point, you could say x equals all real numbers. Now, let's say you still didn't see it. You wanted to keep solving. Go through the motions. Here's x, here's x. You want to get rid of one of these x's. So what are you going to do? Let's get rid of one of them by doing what? Minus x, and it'll cancel, and minus x, and it'll cancel. That's really weird. That's why these are called special cases. It doesn't happen that often, but in this case, it just did. And we have a negative 8 equals a negative 8. When you end up with something that's always true, like 3 equals 3, or negative 8 equals negative 8, or 0 equals 0, what do we say? We say x could be all real numbers. And I might as well tell you this. So this is the answer. X equals all real numbers. And there's a notation for it that you could use to abbreviate. You don't have to write x equals all real numbers. You could say this. X equals, this is the notation, 2 sticks with an R. That's the notation for x for all real numbers. Okay, so it's like an abbreviation. If you want to write it out, x equals all real numbers, go for it. If you want to use a notation, go for it. So once again, let's go back and review these notes. When you end up with something that's impossible, like 0 equals 3, that's no solution. When you end up with something that's always true, like 3 equals 3, or in this case, negative 8 equals negative 8, then you say x equals all real numbers. Now, why is it all real numbers? Because when does negative 8 equal negative 8? Always. It doesn't matter what x is. As a matter of fact, x is canceled out. So you could plug in, you can make x be 3. It could be 3.5. It could be 50. It could be negative 1,000. X could be any number you want. That's why it's x equals any real number, all real numbers. Okay, I hope this makes sense. Let's actually jump to our homework from yesterday, WSPM 4.2. If you tried to do WSPM 2.4, I said 4.2, sorry, 2.4. If you try to do WSPM 2.4, you probably got stuck with questions 8 and 11 because those are special case problems. Let's take a look at number 8. I want to get y by itself on one side. What do? I want to get rid of this minus 6y. Let's get rid of it by doing what to this minus 6y? Plus 6y, that's right. So let me go plus 6y, that'll cancel. What I do to one side, I do to the other. I'm not going to add 6y to the number. I can only add y's with y's. So I'm going to put the plus 6y right below the minus 6y. And of course, that also cancels out. Weird, right? This usually does not happen, but it did. So what do we have left over, guys? We have negative 3. We have negative 3 equals positive 3, right? Right here we had a minus 3, so I brought that down. The equal sign comes down, positive 3. And we have negative 3 equals positive 3. What do you think of that? Is that true or is that false? That's false. It could never be true, so we say no solution. You could abbreviate no sol. And you know what? Another symbol for no solution is a 0 with a little stick through it. That's also a no solution. But number 8 is a special case, right? Let's look at number 11, which is also a special case. Number 11. Let's start simplifying. There is no distributive property on the left. There is no combining like terms on the left. I am going to distribute on the right. So 4 times 3, that's 12. 4 times 2q, that's 8q. That's simplified now. Let me bring down the equal sign. Let me bring down everything else, the plus, the 8q. Okay? So now I want to get q by itself on one side. I have an 8q here and an 8q here. So I have q's on both sides. I don't want q's on both sides, so let's get rid of one of those q's. So I'm going to subtract 8q to get rid of this one. But then again, over here, when you subtract 8q, it messes it up because it's gone also. Weird situation. What's left over, guys? 12 equals 12. Is that possible? Does that make sense? Or is that impossible? Possible. Absolutely, right? 12 is always equal to 12. So what just happened, the q's canceled out. So q, it doesn't matter what q is. It could be any number, and you're going to get 12 equals 12. It's going to be a true statement. So q could be any number you want, all real numbers. So q is all real numbers. So it doesn't matter if you write it out, q equals all real numbers, or you use a symbol, the r with the 2 sticks. So on the back of the worksheet, they say all numbers. But what do they mean by that? They mean all real numbers. It could be fractions, could be decimals, could be rational numbers. It could even be irrational numbers. In other words, q could equal pi if you wanted to. That'll work. Anyway, let's move on. Now you guys don't have this next worksheet yet. You'll get it in a couple of minutes. Today you'll be receiving 2.4 WSP. You should have already done WSPM. Today you're going to get WSP. And the assignment is 1 through 21 odd. We're also going to do number 4 and 22. But since we're talking about this video on special cases, let me actually do number 7, which is a special case. Let's distribute the left side. 3 times negative 2, that's negative 6. 3 times negative 3x is negative 9x. And of course, we're going to bring down the equal sign. And on the right side, there is nothing to do. I'm just going to rewrite it. So that's going to be negative 9x minus 4. So there's my new equation. I have x's on both sides. I have a negative 9x here and a negative 9x there. Let's get rid of one of them. So I'm going to get rid of the negative 9x by adding 9x. And what I do to one side, I do to the other. Now, again, it canceled out. Now, on most of these questions, it doesn't happen. But like these are special cases. What do I have left over? I have the negative 6. I have equals. I have negative 4. This is impossible. What do I say?
No solution.
Thank you. No solution. Or you could do the symbol, right? Whatever you like.